Hello, this is Mr. Stansbury. I'm going to take you through the notes on absolute and percent error. At the end of this, you should be able to say, I can calculate error and percentage error of real world problems. Okay, so first thing, the error is the difference between a measurement and its actual value. Okay, so like if I were to say, oh, I got about $20 in my pocket and I had, say 17, the error would be $3. I was off by $3. Okay, so the absolute error is the size or magnitude of the error. So the absolute error is the VA minus VE, which is the approximate value, and then VE is the exact value. Okay, so I would take the approximate value 20 minus 17, take the absolute value of that, and my absolute error would be $3. Okay, now the percentage error is this absolute error divided by the VE, which is the exact value, multiplied by 100, and that's the percent that you were off. Okay, so what we'll want to do here is take a look at an example that deals with this. Okay, so example 8, Maisha estimates her horse's front teeth to be 4 centimeters long. The actual length is 3.4 centimeters. Find to one decimal place the absolute error and the percentage error. So absolute error here is VA. So we'll do absolute value and then the VA. So remember the VA is the approximate. VE is the exact. So E for exact, A for approximate. Okay, so the approximate value that she gave was 4 minus the exact value is 3.4, right, which gives us 0.6. Absolute value of 0.6 is 0.6. So there's our absolute error. The percentage error is going to be that 0.6 divided by the VE, the actual length, which was 3.4. So we take 0.6, divided by 3.4 and then multiply it by 100, and that will give us our percent, that the percent of error that we had. Okay, so we'll bust out our calculator here and do 0.6 divided by 3.4, and that gives us that. And you can just simply move the decimal over 2 spots here or multiply by 100, and that gives us 17.6%. So Maisha was off by 17.6%. That was her percent error. Okay, so we've got example 9. Pumbaa wishes to cover the back wall of his home with a special sweet-smelling river mud. The dimensions of this wall are 28 centimeters by 16 centimeters. Pumbaa estimated the wall to be 30 centimeters by 15 centimeters. What is the percentage error in Pumbaa's estimation? Okay, so what we're going to want to do is we are looking for the area, right? So what we'd want to do is we'd want to find the area of each, and that's our VA and our VE, okay? The exact and the approximation. Okay, so dimensions are actually 28 by 16. So 28 times 16, that will give us the actual, and then we'll have the estimate is 30 by 15. 30 by 15. All right, so we'll calculate those out. 28 times, try that again. 28 times 16 is 448. And this is what, centimeters? That's the actual, and then the estimate is 30 times 15. So 30 times 15 gives us 450. Okay, so the approximate here is our 30 by 15. So that's 450, and then the exact is 448. So we're going to do 450 minus 448, take the absolute value of that, and that is going to simply give us 2. Okay. So now we take that 2. So this was the absolute error is 2. And now we're going to find the percentage error. So now we're going to take the 2 and divide it by the VE, the exact measurements were 28 by 16, so that was our 448. Multiply that by 100, and that will give us the exact percent that we were off by, or that Pumbaa's estimate was off by, right? So we will take 2 and divide it by 448, right? And we get that. We'll multiply it by 100. And we get that they were off by, he was off by 0.4%, which is pretty small. So good estimation skills, Pumbaa. All right, I've got one last example, but before we do that, let's take a little comedy break.
Good doctor, I think. I told him I get heartburn sometimes, so he goes and gets me a list of things that cause heartburn. I'm looking at the list and I'm like, I already know this. I know how to get it. That's like going into the hospital with a cannonball wound and they show you a list. Here's how you get cannonball wounds. I have a cannonball wound. It's gaping. Do you have a tube of cannonball wound ointment? Number 1, do not stand directly in front of a cannon. How true that is.
All right. Last example here. Example 10. Molly buys a new giraffe welcome mat for her front door. Its dimensions are 36 by 24. Find the maximum percentage error in the estimate. So what we got to do with this here is we're actually going to go back to what we did in the section before this, and there's the rounding error, right? So these are both rounded. Oops, sorry. Both rounded to the nearest unit. Okay, so the nearest, let's see, that's inch. So the nearest inch. So we're going to take 1 divided by 2, and that gives us 0.5. So that means that these could be off by plus or minus a half of an inch. Okay, so what we got to do is we got to figure out the maximum and the minimum in the error, and then figure out what our what the percentage error of that would be. Okay, so we can do 36 plus 0.5. And that's 36.5, and we do 36 minus 0.5, and that gives us 35.5. So that's the biggest it could be, the smallest it could be. And then we also take 24 plus 0.5, 24.5. And then we take 24 and minus 0.5, and that's 23.5. Okay, so the biggest it could be is 36.5 times 24.5, and the smallest it could be would be 35.5 times 23.5. Okay, our actual estimate was 36 by 24. So really what we got to do is we got to figure out the area if it was this big rectangle here, the area if it was the small rectangle here, and then find the percentage error of each, and we'll choose the biggest of those two, and that's because that would be then the maximum percentage error in the estimate. Okay, so we've got 36.5 times 24.5, and then we also have 35.5 times 23.5, and we have the actual, well, the estimate here of 36 times 24 as well. So we're going to want to figure out what all three of those are. Okay, so here's our 3 calculations here. And then what we got to do is we got to figure out which one's got the biggest percentage error, right? So we're going to take the exact, take that away from the approximation, right? Okay. So the exact could have been as high as 894.25. And then the approximation is our 864. Oops, 864. So the absolute value of that. Or we could have had 864 minus our, it could have been as small as 834.23. Oops, 834.25. Okay, so we want to find out which one of these two is bigger, and then we will find the percentage error of the bigger one, and that would be our maximum percentage error. Okay, so let's calculate each of these here. Okay, so here's our two, here's what we get. We calculate both of these here. So this one minus that is negative 30.25, which absolute value is 30.25. This one over here, the difference is 29.75. So this one here is a little bit bigger, so let's use that. So we're going to take 30.25 divided by the exact. Okay, actually we're going to want to do both of these just to make sure. So we're going to want to take the 29.75 and divide that by the exact as well, just because because these exact numbers are a little bit different, right? So we've got 894.25. This is the big, and this is the small. And then we take that divided by 834.25, multiply both of those by 100, and that will give us what our total percentage error is. So let's calculate that as well. Okay, so you can see here from our two calculations, the percentage error on the big one is 3.38% off, and the percentage error with the smaller one is actually 3.57% off. Even though this amount was smaller than this one was, the thing is that the our exact measurement here was smaller than that. That's what gave this a little bit bigger percent. So actually this 3.57 would then be our maximum percentage error in the estimate. Okay. All right, that's all there is for absolute and percent error. If you have any further questions, please feel free to ask. Thanks.